This is our presentation of brazing, soldering, and adhesive bonding. I am Victor Wojciechowicz.
I'm Matt Rothenbaum.
I'm Colton Lambs.
I'm Jose Arazo. So I'll be starting with the introduction about brazing, soldering, and adhesive bonding are all essential methods when it comes to combining materials. Every technique has a unique set of benefits, which makes them useful resources for manufacturers and manufacturers looking for accurate, dependable, and effective methods to put variety of materials together. These processes are expected to develop further, offering more inventive answers to the problems facing contemporary manufacturing and construction as materials and technology processes.
So I will be covering brazing. What is brazing? Brazing is the process in which multiple metals are joined by a filler metal through capillary action into a joint to create a strong permanent bond. Capillary action is when liquid flows through narrow spaces without external forces. This includes forces such as gravity. Brazing uses flux to strengthen the mechanical properties of the assembly. The first step of brazing is to create a proper fit and clearance. Brazing is a process to use capillary action to join metals. Therefore, a clearance must be wide enough to allow the liquid to fully distribute itself, but narrow enough to keep the tensile strength of the joint at its maximum value. Clearances must also account for thermal expansion during the heating process. The second step of brazing is cleaning. Any dirt, grease, oil, rust, or other contaminants in the metals being bonded results in a barrier being formed between the metals and the brazing filter. This barrier causes weakening tensile strength in the joint. Oil and grease is removed first using a degreasing solvent or an alkaline aqueous solution. Afterwards, a chemical solution can be used to remove rust and other contaminants, but must be used after the oil and grease is removed because the chemical solution will contaminate with the oil and grease. Otherwise, an abrasive method of cleaning can be used for other contaminants, but using materials such as sandpaper. The next step of brazing is fluxing. Flux is a chemical compound that prevents oxides from forming onto the surface of the metal. Flux allows the filler metal to bond to the surfaces. Flux generally comes in the form of paste, so a brush is used to apply flux to the metal. In mass production, it is more efficient to use a pre-measured amount of dispensable flux in an applicator gun instead of using a brush. In step four, the assembly has to be positioned after it has been cleaned and flux to be heated. Outside sources of support need to have a poor heat conduction to keep heat in the joint. Gravity is the most common support used in pre-assembly. The main step of brazing is heating. During heating, the filler metal through capillary action spreads throughout the joint. Before heating, you must have proper safety equipment such as gloves and eye protection be worn. A heating source is then used, typically a handheld torch, to apply heat broadly to the base metals around the joint. If the assembly is small enough, then it may be necessary to heat the entire assembly instead of just the base metals. Each section next to the joint must be heated uniformly. After the heating, you deposit the filament metal into the joint directly. The final step is cleaning inspection. After the heating process is done, the flux must be removed from the assembly. This is done by submerging the joint after it is hardened into water and then brushing off flakes that remain. This is necessary because flux can contaminate the joint and decrease the tensile strength of the joint. Finally, an inspection of assembly must be performed to assure the quality of the brazing, which can be done via a visual inspection of the joint or a leak test of the joint. Some of the advantages of brazing are that brazed joints are unlikely to leak if done properly. It can join dissimilar metals such as gold, silver, and copper. It creates overall strong joints and can join fragile pieces of metal. Some of the disadvantages is that it does not create the overall strongest joint. The fluxes may contain toxic chemicals. It requires a clean surface to braze, therefore you cannot braze contaminated surfaces. And that brazing can be a dangerous process as it involves the use of fire, which can damage both the skin and the eyes. Some of the main applications of brazings are the automotive industry, plumbing, the aerospace industry, solar panels, towel warmers and radiators, refrigerations, lighting fixtures, glasses, measuring and calibration instruments.
Now we will talk about soldering. Soldering is the act of joining two different types of metals by the use of melting solder and creating strong electrical bonds. Solder is in itself a metallic alloy made of a mixture of tin and lead. It can be melted to using a hot iron that is heated to temperatures above 600 degrees Fahrenheit. The metals themselves, which can be used, some are lead-based or some of them are lead-free, but most of them will be lead-based, and they will consist of antimony, bismuth, brass, copper, iridium, tin, or silver. Soldering. There we go. A soldering iron and a soldering gun are two of the most used items for soldering. For the soldering iron, it heats solder above the melting point of the metal alloy. Solder flows between the two workpieces needed to be joined, and keeping the tip of the iron clean directly impacts the success of soldering. If it's not clean, similar to brazing, if there's stuff on there, then it will hinder the strength of the joint. You use a wet sponge to clean the tip of the iron in order to make sure that does not happen. For a soldering gun, it heats solder to a much higher temperature than the iron. It's used for joining stained glass, light sheet material, and heavy electronics. Solder cools much quicker when you're using a soldering gun. And another thing is a soldering tool. Solder can be removed using the desoldering tool if you've added too much or you decide that you no longer want to use soldering for whatever project you're using. The advantages of soldering is that it can be operated at low temperatures using a solder iron and high temperatures using the solder gun. This just means there's a big variancy in what you're doing. You have more options. The base metal does not melt. Your soldering gun is not going to melt. Your soldering iron is not going to melt. And the actual metal that you are soldering to is not going to melt. The only thing that will melt is the solder in the middle, which is combining the two joints. This means that the tools you use do not melt, and just the solder is affected. Any metals can be joined due to the high temperature variance using the soldering tools. And soldering takes very little time to join the two metals. The process takes a matter of seconds, and then obviously it uses a little bit longer to cool down. Disadvantages: the strength of the joint that has been joined by soldering is not that strong. This process of soldering is not useful on joints that will have to be working under conditions of high temperature. The solder will melt. So if you're soldering something that's going to be put into an oven, or it's going to be heated up past 600 degrees, the solder will melt, the joints will break, and it will not be useful. Heavy metals cannot be joined with this process due to the fact that the solder joint is not that strong. Even if you keep the tip of the soldering gun and the solder iron clean, it's not that strong, and it's better used in precise small areas. As we lead to the next one, this method of soldering is not strong for long lengths of welding. Applications: soldering has many uses in many different areas of work. due to its just variancy of when it could be used on. Automotive, it's everywhere in automotive, plumbing as well, aerospace, medical, jewelry. Basically the biggest appeal of soldering is that it's completely reversible using a soldering removing tool. And an example of soldering being used is when electrical parts are involved. There's lots of soldering involved in circuit boards, or when you have copper joints between two copper pipes in plumbing.
All right, our final topic of the night is adhesive bonding. Some people may ask, what is adhesive bonding? Well, to answer the question, adhesive bonding is the process of joining two surfaces together, usually with the creation of a smooth bond. This may involve the use of glue, epoxy, or one of a wide range of plastic agents with a bond either through the evaporation of a solvent or through crying via heat, time, or pressure. During adhesive bonding, materials are bonded on a molecular level. Materials are able to bond due to the cohesive forces between them. And then when creating these bonds, the cohesive forces are disrupted at the surface of the material because there are no molecules to interact with above the material surface. This kind of disruption leads to the excess amount of energy at the material surface, which is called surface free energy. And surface free energy is when molecules from one material are available to bond with other molecules. The higher the surface energy, the stronger the bond will form with other materials. All right, so to get into the process of adhesive bonding, the first step is going to be degreasing. The first step in the adhesive bonding process is degreasing. It is very critical to remove any contaminants or previous adhesives so the new bonding will adhere correctly. Usually, manufacturers will use a type of solvent to help speed up the removal process. Degreasing is often performed with a solvent known as vapor degreasing. Surfaces are submerged in a solvent that dissolves the grease. Manufacturers can also wipe surfaces with a solvent-soaked cloth. It's a little bit less efficient, but it is also an alternative if some companies and manufacturers don't necessarily have something that they can submerge materials in. The next step is abrasion. During abrasion, the surfaces are prepared by exposing them to abrasive material, such as sandpaper. The idea here is to increase the surface area which the adhesive will be exposed. While this makes the material surfaces rougher and more rugged, this also allows the adhesive to spread to fill the micro-sized cracks and crevices, creating a stronger bond. Moving on to step 3 is the adhesive. After degreasing and exposing the material, the adhesive can now be applied to the material. During the adhesive process, the adhesive is carefully applied to both surfaces. These adhesives can be both organic and inorganic, but regardless, they must be able to create strong bonds and prevent the surfaces from splitting or separating in the future. And then moving to the final step, step 4, curing. The final stage of adhesive bonding is curing. Not all adhesives require curing, but many do. A common curing method is heating. When adhesives are heated, a chemical reaction occurs that strengthens its bond. Some companies use large commercial drying ovens to speed up the process and make it more efficient. To dig a little deeper into adhesive bonding, the first concept I'd like to talk about is the stress design. Stress design depends on the ease of joint formation, the stiffness of the material, whether the material is homogeneous or laminated, and the strength requirement. Stresses in adhesive bonds are usually a combination of two or more of the following. There is shear joints, tension joints, compression joints, cleavage joints, and peel joints. As we have shown here on our slide, a little demonstration of each type of joint. And then along with these stress joints, there is also the different bonding joints. So when using adhesive bonding, the materials must be joined a certain way in order for the bonding to be effective. Joints tend to be stronger in the shear and tension than in the peel and cleavage joints as shown on the previous slide. These joints must be designed to sustain loads in ways that utilize their strengths as well as their weaknesses. So as you can see, there are multiple and various types of joint designs, but the most common used in industry and manufacturing are going to be the simple butt joint, the scarf joint, the V joint, the tongue and groove joint, and the plain lap joint. So some of the advantages to using adhesive bonding are there are even distributions of stress loads between materials. Stress concentration and adherence are small. They are invisible within the assembly, making them almost seamless. The connections and bonds they create are very stiff. There is little to no deformation in the substrate between material. Very little fatigue resistance. There is reduction in other components such as screws, nuts, bolts, etc. Not only is it adhesive, but it's also a sealant. It is very lightweight and it is very versatile. Some of the disadvantages of adhesive bonding are it is easily prone to failure. It is not good with high heat or weathering. It does require a lot of surface preparation, which is where the degreasing comes into, as well as making sure that surfaces are in the right state to be able to be adhered together. They can cause some disassembly issues when it comes to taking things apart or when it comes to repairs. Difficulty of inspection procedure. There is high degree of quality control. There are some environmental concerns. It can lead to costly tooling and facilities which may be required. It may also be subjected to environmental degradation, which kind of goes hand in hand with the environmental concerns as well as the disassembly issues. And it also can have long curing periods requiring, a lot of time, which means higher cost too, which would slow down production. So adhesive bonding can be used in many applications and have many different uses. Some of the applications where adhesive bonding is used in manufacturing are the following. There is your door and window assembly, transportation industry, HVAC manufacturing, construction material assembly, prefabricated houses, packaging, aerospace, agricultural machinery and equipment, security tapes, the energy industry, woodworking industry, the medical field, as well as textile.
So we go to wrap up. In conclusion, adhesive bonding and soldering and brazing are essential methods for using material in varieties of sectors. Strong heat-resistant junctions are the best created by brazing. Incentive electronic components works best with soldering and adhesive bonding. Provides an adapted, essentially freezing solution. These techniques will probably change as technology develops, but they will still be essential for efficiency and a dependable material connections in production and construction. When combined, they demonstrate a combination of science and art industry, enhancing robustness and longevity and the visual appeal of contemporary goods. And lastly, these are the resources we use to find the information of adhesive bonding, bracing, and soldering.